Problem 7. What values of a and b make the function f continuous everywhere? Fx is piecewise defined. This expression, if x is less than 2, the second expression, if x is between 2 and 3, inclusive 2, and the last expression, if x is greater equals 3. So you see a and b, you need them to be some numbers so that this function is continuous. Find those a and b. So I've rewritten the question here. This is piecewise defined function. That is, your function is defined on pieces. Notice this piece, if x is less than 2, yes, that is x is not 2, you notice this is equal to the fraction upstairs is x plus 2, x minus 2. Downstairs is x minus 2. Sorry. So x minus 2 cancels x minus 2 if x is not 2, which it isn't. And you get x plus 2. You understand? So, in other words, x plus 2 alone is a continuous function. So, to the left of 2, I am continuous. Between 2 and 3, this is a polynomial. It is continuous. No matter what a and b, this is a polynomial. Beyond 3, this is also a polynomial. No matter a and b, this is a polynomial. So it's continuous. That is, fx is piecewise defined. On each piece, f is a polynomial, therefore continuous. See, even in the first piece, this is actually a rational function, but when I cancel, I get a polynomial. Okay? So it's therefore continuous on each piece. The only issue are these cut points, x equals 2, where there is a change, and x equals 3, when there is a change. So we need to make sure that our function is continuous at these cut points 2 and 3. To the left of 2, the first expression takes over. Between 2 and 3, the second expression takes over. And after 3, the third expression takes over. So first f, that is first function, second function, and third function. Okay? So I want to be continuous at 2. In other words, the limit x approaching infinity of fx, I want it to be equal to limit x approaching, not infinity, limit x approaching 2 from the left and limit x approaching 2 from the right, and the value at 2 must all be equal. That's the hope. Okay? So, when I'm approaching 2 from the left, I'm on the left, so my first function takes over. That is, this expression takes over. Well, x squared minus 4 is x minus 2, x plus 2. Cancels the x minus 2 because I'm not 2 yet. Get rid of them, I get x plus 2. Limit, now I plug in x equals 2, I get answer 4. Whereas when I'm coming from the right, the second function takes over. Second expression takes over. So that's my second expression. I want x approaching 2 of this expression. Well, there are no denominators, nothing to worry about, so I plug in 2. I get 4a minus 2b minus 30. You understand? I just plugged in x equals 2. For f to be continuous, I want right hand limit to be equal to the left hand limit. Okay? So 4a minus 2b minus 30 has to be 4. Move the 30 to the other side, 30 plus 4. 4a minus 2b is 34. Divide throughout by 2. 2a minus b equals 17. That gives me one equation. Now the other cut point is 3. Left hand limit to 3 and right hand limit to 3 must be equal for my function to be continuous, okay? And the value, of course, but value is given on the right hand function, you see. So that's okay. For the left hand limit to 3, well, if I'm to the left of 3, I'm looking at second expression, which is ax squared minus bx minus 30. Plugging in 3, I get 9a minus 3b minus 30. I hope it's clear. When I'm to the left of 3 but near 3, I am here. Okay? So I'm in this expression. Whereas when I'm to the right of 3, I am here. So I have to use this expression. Okay? So right hand limit, I have to use 16x minus a plus b. Plug in x equals 3. I get 48 minus a plus b. Okay? Left hand limit must be equal to right hand limit. So this expression must be equal to this expression. Okay? Now it's just manipulations, right? I'll get the a here and I'll get the b here. So minus a becomes plus a on the left, plus b becomes minus b on the left. I'll take the numbers on the other side. So minus 30 went to the other side, became plus 30. 9a plus a, 10a, minus 3b minus b, minus 4b. I can divide throughout by 2. 5a minus 2b equals 39. So this gives me another equation. If you remember, I had one equation here and here is another equation. Now I have two variables and two linear equations. Okay, this is something that you have seen in your earlier classes. Solve for a and b. Well, looks like I can focus here, yeah. Multiply the first equation by negative 2. So that gives me negative 4a plus 2b minus 34. Why did I do that? Because plus 2b and the second one, negative 2b, will cancel. So add them both. 5a minus 4a is plus 1a. These two go away. This is 5. A is 5. I got a to be 5. Substitute in either one of these. I'm just substituting in the first one. 5 gives me a 10. Minus b is 17. Move the 10 over. Minus b is 7. So b is negative 7. So I have a equals 5 and b equals negative 7. Oops, I got kicked out. Okay, so that was correct. All right. Next problem, next video. Okay, until then.